So, today's subject, SQL injections. Finally, I talked about this all beginning of the year. We finally get into the cybersecurity, exciting vulnerability type of stuff. SQL injection this week, cross-site scripting next week by Adam, if I'm not mistaken. Okay, perfect. So, getting into the midst of it, all the interesting stuff, let's go right into it. So, firstly, before understanding what is SQL injections, what is SQL and everything, we need to understand what are databases initially. So SQL, and you're gonna see this acronym very often, is a select query language or structured query language. I never remember, but it's a language that is used to interact with the databases that you will have. NoSQL, relational databases, or even cloud-based databases. All of these will have some sort of SQL dialect used to interact with them. So that's where SQL is. But on databases side, what is databases? So you on your initial, or you're used to your Windows system, you have all your files stored together. This is a file system, so if you click on university, maybe you have your different courses, maybe you have something else, file system. Database system, collection of data, everything stored together, but in different tables and different rows, and this is how it's sorted. So typical example would be, for the university, we're thousands of students. Each one of us has an ID, so 7 something, a number like that. It's our ID. And we have a name, date of birth, genre, nationality, everything is associated. And this entry, which is for you, with your ID, your name and everything, is a row like A-R-O-W, in the database table that would probably be users. So a database is a big collection of data, and there exists multiple types of databases, cloud databases, NoSQL, so MongoDB and Redis that you might have heard of, and relational SQL, which will be the main topic of today. What is SQL? A lot of text, you don't have to read everything. It's just to give info for the people that won't be able to attend today's lecture or will have to recap on the website. But for us, what is SQL? It's a programming language. It's like Python, Java, or anything like that. But it's a nice one because it's in English and it's not with commas and everything like that. I mean, there are a bit of commas, but not very much. And it's a very nice one because you can read it in English and it's structured to be like the English language. So we all love SQL because it's nice. Structured query language. It's very fast to query big databases, collections of data. Very easy to learn as well. Probably if you already seen Python, probably going to learn SQL in a week. Probably could be able to not master, but have the good knowledge about SQL in a week. Very reliable and very flexible as well. You can store really whatever you want inside. So, I talked about the dialects, SQL dialects. What am I talking about? Is it hieroglyphs? Why am I talking about dialects? Is it different SQL languages? So, there is a standard of a syntax in SQL that you will see almost everywhere. The standard for this syntax is the keywords select, insert, update, delete, where, and join. These are keywords. In any SQL dialect, you will see these keywords. Otherwise, there will be some differences in dialect functions or anything that gets a bit more complicated than the basic interactions like this. Functions, for example, the length function will not have the same orthograph in different dialects. So might be the len, might be length, might be char length. You get the idea. It means the same thing. You won't have nothing that is totally different, but it might have the different syntax and might gonna push you to look online even if you already know what you're looking to do. So very common dialects you might have heard about. MySQL, MariaDB, PostgreSQL, SQLite, Microsoft SQL Server, because Microsoft always has their own stuff. We don't know why, but they really like it. And Oracle SQL. Most probably you've worked with SQLite if you worked with DBs in Python. If not, MySQL or MariaDB is the typical standard SQL dialect everybody uses. But you feel free to use any of them. So, as I said, the differences, certain functions, certain data types, certain operators as well, and advanced features, but on the basics you will be able to do everything with these keywords on any dialects. All dialects speak SQL with just different accents. I like this one. It's quite nice. So what is an SQL injection? Now that we see stuff about databases, now that we understand that SQL is a programming language, you're going to ask me, why am I supposed to inject something in a programming language? So, for those of you who've already seen SQL, this syntax might seem very, very similar. For those of you who've not seen SQL, let me just break it down really quickly. So, as you've seen before, we have keywords, select, insert, update, delete, where, join, and I said SQL is almost English. So this query right there, this one, just the second line, would say, from, the star means all, from all, select everything from my user table, where the user ID will be what my user inputs, which is text user ID here. So when I say select star, that means get everything. From the table user, in a database there are multiple tables, the table user will probably store username, password, ID, stuff like that. So in this table, ID will, which is here called user ID. So from the table user, where the user ID is this, grab my row. So here it would just be grab a user from its user ID. This is the SQL statement that would do that. Why is this vulnerable right here? Because I simply put what the user inputted and I simply put it in my statement without checking anything. But did we not tell you anything about never trusting user inputs? And that's the biggest mistake that developers make. They think when they develop a website that everybody's going to act normally, that they're not going to try to break anything, and that there's going to be no random inputs, nothing like that. But that's always the case. Every time you'll have some people that are going to try to break your website logic, and if you don't have guards in place, this statement could be used to retrieve passwords, usernames, personal identification numbers, and if this is a specific dialect of SQL, you could also even execute commands via SQL queries. So, problematic. So, SQL injection is fact of injecting SQL statements. So you would insert something here which would also be in SQL programming language. You would not input just a random string. This is what happens when the user input is not checked, not sanitized, and you can do anything you want from there on if you have control. And it's one of the most common web vulnerabilities. So if you guys ever seen that or never seen that, now you know that it's most probably still 20 years after its discovery, one of the most common web vulnerabilities and one of the most devastating ones as well. So how does that happen? How do we get there? And why do developers, when it's their full-time job, make mistakes that seem benign and shouldn't be as impactful as they are? So, because user input is not validated. Because the guys, when they code this, they don't check. And when you don't check, you get surprises. So this is a major problem. Seems easy to bypass, seems easy to say, okay, I'm just going to check that there's not this or this in my statement. That's it. It's not as easy as that. Nowadays, it is. But at the time of the people that coded legacy programs, it was not easy as that. Unsafe string concatenation, same stuff, not validated or sanitized. Here, you know when you're in Python, when you add the pluses to just concatenate stuff without checking, this is non-parameterized query, this is dangerous, and this is injectable as well. So be careful. People trust users too much, missing prepared parameterized statements, so same thing, you need to validate and sanitize. You have old code, legacy code, that is also vulnerable, but that hasn't been checked for ages, so people will still run on that. And one day, 20 years later, a guy that's doing a bit of security is going to realize, oh, damn, we were vulnerable for 20 years. Okay, that's a problem. So always check your legacy code or poor error handling as well. Because one of the biggest vectors for SQL injection is when you have a big error message that shows up saying, oh, you put a comma, everything's broken. If as a pen tester I see that, I'm brushing my hands and I'm very, very happy. I know I'm going to have a nice payday incoming. So be careful with your error messages. When they tell you never put the debug mode when you're running Python Flask or when you're running anything, because it gives you too much info with the debug messages and you can do stuff like that. So why are they this popular? As I said, it's easy to exploit. It's not very time consuming if you know what you're doing, and it has a huge impact. You can get all the confidential data, the data leaks, the databases, everything you could think about, even full compromise. In some cases, you can execute commands via SQL databases. Very, very dangerous. Large attack surfaces, you can attack from anywhere. You can attack from HTTP headers. You can attack from URLs, from API endpoints, from your cookies, from forms, from anything. So it's easy, it's fast, and large attack surface. I mean, why wouldn't you try? Because it's just telling you that it's going to be nice. So yeah, this is something that is quite nicely seen in the cybersecurity world, and people really enjoy SQL injections. So it's very well documented as well, and it's very high reward or big ROI. So if you do finances, you know that the return on investment on your SQL injection statement is going to be nice. So, okay, now we have a basic grasp. What are SQL injections? What do they affect? Databases, SQL. Now, there's not only one type of SQL injection. There's three big categories: the in-bands, the out-of-bands, and the inferential. Weird words, very not very friendly, but you'll see it's quite quick. So as you can see, there are two big families: the in-band and the inferential. The out-of-band doesn't have anything branching out because it's a smaller family in itself than the in-band and the inferentials. Today I'm going to talk a bit about the in-band, so the error-based and the union-based, and only about the time-based, because the Boolean-based is, the time-based is just an extension of the Boolean-based. Quickly on that, stop me if I'm too fast or if I'm not clear at all. Okay. So, first one, the in-band SQL injection, the one on top. So this one is the most common one, not to say the simplest one, because it can be quite tricky, but this is the easiest one to detect and to exploit, because you have an error message, or you have some sort of output that enables you to pull out the data or what you're trying to pull out in the same channel as the channel you're attacking. So you're attacking a website, you'll get all your recovered data on this same website. No need to open up another web page or redirect your answers somewhere else. No, you attack somewhere, you get their answers from the same place, easily done. Two main types: error-based, union-based. Responds directly, and the thing that makes it called in-band is because it's an injection on the same request response, on the same resources in itself. So the real difference between in-band and out-of-band, as you can now guess, out-of-band is outside. It's not, you would have to have different channels running to grab your data. So you would inject on a website, but you would grab your data somewhere else, maybe via DNS calls, maybe via another web page that you set up, a URL request or anything like that. So that's it. And inferential, it's a bit of both. We'll see just right after. So inferential right here. No direct data or messages. Unlike the in-band, this one will be a bit more hidden, a bit more complicated to maneuver around, but still doable. Main types, a bit boring because you will spend a lot, and I'm saying a lot of time doing your Boolean-based or your time-based SQL injections when you don't have any outputs. The only way to know if you're doing something correct in a time-based is waiting, which is the basic of the time-based SQL injection. Because if you wait, maybe put a timer, say, okay, if my query is correct, wait 5 seconds. Wait, maybe the web page is going to take 5 seconds to load, then you know your request was correct. And after, if you have to continue and try to find, for example, the password, then you have to guess letter by letter, or number by number, or symbol by symbol, until you reach something that is correct. So, is it A? No. Is it B? No. Is it C? No. And you do that, and maybe the password is 26 characters long, and you can guess how much time it's going to take you. So, this is very nice. When you don't have anything else to do, you can do it, but it's extremely time-consuming if you are not using automated tools, which we will come after. So, no error message, nothing you can see. Try blind SQL injection or Boolean-based injection, inferential, which is maybe another solution. Or in the case that you don't have inferential or in-band SQL injections, you can try out-of-band SQL injections. So you have to extract your data from somewhere else, as said right here. You cannot extract it via your normal thing, your normal, oh, I put my request here and my response is here. So it works when results do not appear on the page, the time-based blind SQL is too slow. Sometimes it can happen. Your initial request time might already be 5 seconds. If you add 5 seconds on top of that, and you're trying to guess your password of a user, but first you need to find the name of the table, you need to find the number of columns, all that things. I mean, you can take absolute days. So sometimes out-of-band is just better. And sometimes the database supports external network functions. So you can send DNS requests or open specific things via your SQL query. Quite useful. And yeah, that's it. So this is when out-of-band SQL injection comes in. So in-band, same place, request, response, everything sorted. Inferential, you don't have any output of your response, but you can see if it works or not. Out-of-band, where nothing works, out-of-band. It's the best way to remember. And you can get your answers via DNS lookup, HTTP callbacks, or SMB requests. On Windows, it's easier, but you can do Samba on Linux. So, something you need to keep in mind, I'll go quickly on this one. When there's a SQL query, there are the conditional SQL statements and the retrieving statements. SQL is going to be used for multiple things. Validating a username password when you create your website, you're going to use SQL. If username is this and password is this, then allow access. Okay, in this case, you bypass it by making the condition true. As simple as that. If you're checking for a condition, as long as you make it true at the end of the day with a statement saying that 1 is equal 1 or something like that, then that's it. Your username might not be your username, your password might not be your password, but if at the end of the day you have a true condition and say, or my true condition, the true condition is going to be true, and you bypassed the statement. If you can inject your SQL query. Is it clear? Okay? All good? Okay. Nice. Then, in the other case, sometimes you have SQL queries and statements that are used to retrieve data. Instead of validating with a condition, you will retrieve. In that case, you can use specific techniques to retrieve different data and to retrieve data that interests you and to return this data to you as well. So in this case, you will not make it true. You will make it return more than it's supposed to return and show it to you. So, in-band SQL injection, error-based. The first one, the most common one, if you did your second year coursework, I'm not sure there was the error-based one in the SQL injection for the second year course. When you tried, no output. So it's not an error-based then. It would be because you're not trying. Yeah, conditional blind statement then. Yep, I think it was, you're right, because there was no any error messages. Okay, no problem, back to it. So, first one, if you want to you do your basic SQL injection on a web page, you know there's a database running behind, and you get an error message when you input the wrong username or the wrong password. Maybe this error message is linked to the database state, and maybe if you input a tiny comma, just a tiny comma like this one, it can break absolutely everything. So as you can see here, this is an example. Sometimes you will get an error message and you will get the actual database error message under when there's debug mode that hasn't been disabled or things like that, just by inputting a tiny comma. Why the tiny comma? Because as if in an SQL statement, as you can see, when you have SQL statements, why is there too many commas here? No, not this one. Yeah, here, like here. When you will put your input, it will be something in quotation marks. Most of the time, a single quotation mark. And when you put your something like this, and when you put a quotation mark, like the example here, you will automatically say, oh, I forgot my markers. You will automatically say that you end the initial query, and then the rest of what you input will be code, will be interpreted as code and not as a string that you were initially supposed to put. So it's shit. I would like to write something down, but okay, no worries. And so it's really terminating your string, your input string, and saying oh, and add these instructions at the end as well. One thing that is also very useful is the two slashes, the two minus that you can use. It's called a comment in SQL, and you can comment the rest of the statement. So you can, for example, here say this or 1 = 1, and comment the rest. So all the rest will be forgotten, and you will just say, okay, I add a true condition in this, making the whole statement true, and at the end of the day, it'll give you access to what you're trying to get. So your account info, if login count is nothing, user ID is nothing, but 1 = 1 at the end, which is true, one of the three conditions that are here now will be true, making me get access to the account info. Hopefully it's clear. Hopefully. Okay, all good? Okay. So when you're doing that, most of the time it's due to the fact that you have a injectable place, and you also have a very nice error message telling you exactly what is going on. And most of the time it contains the keyword SQL. When you try to inject on input text box like this, most of the time there is a DB behind running with data. Quick example. Here, a payload that we would use, a very common payload, is quotation marks or 1 = 1, and the comments at the end. Here, for example, if I have this URL like this at the end, ID = 1, I can try adding a small comma like I just did here, and I will get a big error saying that there's an SQL error. Once you see that, bingo, money in the bag. Once you have seen that, you have SQL running. Once you know there is SQL running and you can start injecting things, then you can start. You can start doing your game. So trying to find out how the initial query was made. Like this, select all from my table articles, where the ID of the article is this, and this we can guess is the URL parameter ID, which was inputted here, and release = 1. We can imagine this was the constructed query. If that was the case, on our website, so forget the fact that it's not the same URL, I did mess up a bit on this one, but imagine this is the case, and you have this released parameter at the end, but you cannot manipulate it. As you can see in the URL here, you don't have any control of the released parameter. But if I start injecting and adding comments at the end, so imagine this was my ID = 1, and I just add comma and my comments, then it will automatically comment out all this part of the query that was initially made, making me stop at gifts. And I will get the released and unreleased released gifts because I removed the end of my statement by adding a comment, by injecting a comment in my URL. So here, what the website URL would now look like would be ID = 1, comma, minus being comments. I commented out the rest of the statement, and now I bypass the filter. Ooh. Okay, so this was the error-based. Hopefully it's clear for everyone. Okay, perfect. Now, union-based. So for all the people that don't like math, I can give you it's a nice statement. We will not do math because I'm very bad at it as well. But union, if you remember from your math stuff, a union is just the total of, sorry for my limited vocabulary in math, but it's just the total of, if you take A and B, the union would be everything within A and within B, and just bring everything out. This is a union. So there is a statement in SQL called a union-based SQL injection. You can combine an initial query that is fetching something with your query. So imagine this initial statement was select and I will add a union at the end saying, and with this also give me something else. And this is where the union comes in when you want to fetch extra data from an initial request. But very important, you need to know how many columns are returned from the original query before you inject your union. So imagine the initial query was select A and B from table 1. I injected union in that statement. If I select only C, it will not work because I don't have the number of column that the initial query adds. So if it takes A and B, I need C and D, D and E, or F and G, or whatever you want, but I need 2 of them because it will not be the same length and you wouldn't be able to do union-based SQL injection otherwise. Other info, you need to know which column returned from the original query have a suitable data type to hold the results of too complicated. Simply put, if your initial column returns only string data, your extracted data is a string, you can only return it from a table that will give you string data. Because if you try to get it out from an int table, it will not work because it's a string. Well, that's it. So, quick example, non-exhaustive example for the order by and for the union. You need to imagine that you will do this process until you find something suitable. I just put 2 iterations here, but you understand the example. So, common payloads for union-based. You order by. Why do you order by? Because when you order by, you can start counting your columns. Order by 1, order by 2, order by 3. Once you get an error, that will mean that you're ordering by, because the number you put instead of n is an index of your column in SQL, you can order by the index, making it perfect for counting columns. If you want to start counting columns and you don't know how many there are, you order by 1, 2, 3, 4, 5. You'll get an explicit error when you reach order by that is too high for your number of columns, and then you'll know how many columns you have. Perfect. Okay, imagine I found out I had 3 columns. Then I can start selecting by 1, by 2, by 3, by 4, by 5, or how many columns you have. And then I will start guessing username, password, number of names of the possible columns, things like that. I can do the same method of iterating letter by letter if I don't have any outputs on my terminal, being blind. If I do have an output and I see error messages or anything like that, then I can guess quite faster than only with letters. So to determine the orders of the column, you can use the order by method, or you can also use union select null, null, null. You can imagine there will be 3 nulls on this one, after 4 nulls, until you get an error message saying there is a column that doesn't exist or something like that. You can only union with the specific number of columns of the original statement. I think the error message says something like that, meaning that you have reached too many columns. So you just find the number of columns where you don't get an error message, and that's it, you're sorted. Next, determining a correct data type for your extracting your stuff. Just put a string instead of null. If it works, that means you can extract a string from this, so the data type is a string. You got your extractable data type and your number of columns. You can start working. Now, quick question. Suppose that original query returns 2 columns, both of which can hold string data. The injection point is a quoted string within the where clause, so you need to have a bit of knowledge about SQL structure. And the database contains a table called users, where the column and username and password, with the column username and password, retrieve the contents of the users table by submitting the inputs. How could I submit? What input could I submit? Anyone has an idea? I wish I had taken my whiteboard marker so I could have written on somewhere, but... So, imagine a structure similar to something like that. Yeah, to something like that. Original query, 2 columns. Okay, 2 columns, original query. Does that, yes?
I was going to try to provide an answer.
Go for it.
Would it be something like apostrophe, union, select, and then you don't put the name in the second table, is that right? So it wouldn't be apostrophe, union, select, username, comma, password from users.
Yeah, that's it. So that's exactly that. So as you didn't rightfully forget, never forget the comma. It's called the comma, right? This one.
Apostrophe.
Yes. Apostrophe. Sorry, yeah, my bad. With the wiggly wave and this one, I'm still lost. So apostrophe. Apostrophe will because it will enable you to break out of the initial statement. Once you break out, you just code code in SQL. Union select just meaning select something else. So select give me the username and the password from users. If there's 1,000 users, you'll get 1,000 usernames and 1,000 passwords. If you want a specific username and password from a user, you would add a where clause after, saying from users where username equals something, bringing you only the username and the password from the user with a specific username. Yes?
So I don't quite understand the significance of having to determine data types of the columns.
It's for extraction of your data mostly. So to be awfully honest, I've never had an issue with that. So extracting the data in those cases as well, because it's not blind or because you have a bit of outputs, you wouldn't really need to determine the correct data type. But in certain cases, you do have to know how to extract, where to extract. Maybe a column, you will try to, what would be a good example?
If it's a non-serializable data type, like a binary.
More like if you would like to extract, for example, if you would like to extract a password, but the password would be only numbers, you could spend a lot of time trying the strings, and might be faster if you try the integers directly. In that case, for just a speed reason, but other a reason for the data type would be probably extracting the whole data when you don't have outputs. So when you don't have anything, you need to know the data type.
Wouldn't a faster way to just be to say select db master dot the name of the database and then dot the table and literally get the metadata about what the columns are?
If you can get the output of your data, the table name, because you can use the schemas to get table name out, but if you don't see the result of your SQL statement, then you cannot get the table name out, except if you iterate letter by letter. So maybe I think for me that would be the only reason you would need to determine the correct data type. To be honest, I've never had to determine the correct data type to extract the answers, but maybe because the statement that I was manipulating were made for competitions or stuff like that, so they expected this. But I don't know. No, it's a good question, to be honest. I'll have to look a bit more into the correct data type. The ones that really insist on this are Port Swinger for Burp Suite, so I'll need to take a look at why exactly they really insisted on the original data type, but why I assumed when I was doing this was that it would be extraction relevant for specifically union based, because you will extract from data tables that you might not know exactly. I'm not sure. I'll have to double check more in depth. But that's a good question. So yeah, you were right. There is this was exactly the statement. So if you stop with the apostrophe, escape the statement, username password, get users from just get username password from the users. Comment out at the end. Don't forget that. But in order to perform this attack, you need to know that there was a table called users that exists before, and if you don't know that, you would need to iterate through and guess the name of the column, or just go letter by letter using Boolean technique. So, time-based SQL injections. Before I go over time-based, I'll go over Boolean-based injections, because time-based are just a bit more complex versions of Boolean-based. Do I have an example I can use? Yeah, so this is nice. So here, the only thing new would be using the sleep function that, as you can probably guess, would make the program sleep and would give you a bit of insight on how the program is running. If it sleeps for 5 seconds, that means your executed query was true. If it doesn't sleep, that means that it didn't execute, so it was false. So here, Boolean-based and time-based are very similar, as was said at the beginning. You don't have any output. You don't have any way of seeing what's going on. How do you handle it? Boolean-based, you would have an output of true or false. So maybe you would have a variable on the web page, a header saying identified or not identified, that would tell you if your query was true or your query was false. In time-based, you don't have anything making you have to use the time. So in Boolean based, maybe say to try to determine, try to extract a username, try to extract a password. Firstly, you need to determine table name. Then you need to determine column names. Then you need to determine a bit of the schema. Then you need to determine maybe if there's a after the column names, how many items are in there. Maybe you want to extract as only the first 20 rows. Maybe you want to order by something. So to do this takes a lot of time. Takes a lot of time and a lot of patience if you don't have the correct tools. But it's always better than the time-based one, because the time-based one, you will have to add time, and if you already have something that is taking a long time, maybe you're 15 seconds for each request, it's not viable. So sometimes you just have to rely out of bonds and in inference. Sorry, I think I might have made a mistake here. I did make a mistake. Sorry, so I wrote in-band SQL injection here, and it's not out of band, it's inferential. So I did make a mistake. Sorry, time-based and just time-based. It is inferential, not out of bands. So yeah, sorry, mistake on my part. So yeah, just to quickly go on it, it will be something that you will see if you do challenges. Most of the time, you will get SQL injections to do, but you will not get output. Use the keyword sleep for a function. Add some time. Check if the time, when you add some time, the response is modified. If you have anything that tells you, if you said sleep 15 seconds and the functions and the program sleeps 15 seconds, you're probably onto something. And just when there is no data, no errors, no visual changes, that's really when you have nothing else to do. You go on the time-based. So same structure, you have an initial query, you break out of the query with apostrophe, and then you start adding some stuff. So you'll say, and sleep 5 seconds, and you comment out anything. That would be the initial testing query, where you would see if it responds to a sleep or not. If it does respond to a sleep, then start breaking stuff. Here, second SQL query you'd see here would be to get the version of the database. As you can see here, if I'm testing to see if the first string, if the first letter of my version is a 5, so I'm just using the substring function and add that version to get my version. Then I check out the first character, and if it's a 5, then okay. And with the version, in that case specifically, with the version, I can maybe see if there are initial and inherent vulnerabilities, or if it's not the version, I can start iterating on the names, column names, and see if I can pull anything. So it's very slow, as I said, row by row, character by character, table by table, and at the end of the day, you will get results. But good luck, and I hope, very hopeful for you. You're using automated tools. So as I said, exploit will be something like that. You will just add a sleep and you use up the time to see if you have a correct answer. So one thing that you might have not seen, even if you did a bit of TryAcme, are second-order SQL injections. Second-order SQL injections are not as complex as time-based or anything else said before. They're called second-order because they're not executed the first time you inject. You might inject something, and it might not be used directly. It might be used in the next statement that is made by the website. So, for example, I have an input, a username, or I am asked for, I'm asked for a color, my favorite color, and I inject in the statement. First time I inject, nothing happens. Then I go on the main homepage and it asks me to set my color. I set my personalized color with my injected payload that I injected that was already executed. And this time, while running through the database to find my color, it executed my payload, but it was not executed the first time. Only again, when the second time the statement passed through. So this one will happen very, very commonly, less in competition, more in realistic scenario where you would have a SQL injectable statement, but you wouldn't have any any outputs that you could see. Then running around the website, clicking stuff might make you trigger the second call for this SQL injection and might make it execute. So malicious input is stored first, then executed later. Injections happens in the different part of the application, making it quite tricky and very hard to patch for developers. Often bypasses the filters and the web application firewall. So WAF is web application firewall because it's not executed straight away. Makes it seem like a genuine query executed by the application. That's why it makes it so dangerous. Common used in user profiles, very used in user profiles where you set custom things, not executed straight away, but then when you use your custom things, that's where it's executed, and that's where your very second order SQL injections really come into hand. And they are stored, but they're reused, and that's what triggers them. So, one other thing. You can inject via HTTP headers, which makes it even more dangerous than was initially. So, most very common headers that are used, and I'm going to tell you where they're used, are user agents, referrers, exported for, and cookies. Why would you think these 4 headers would be very used in a data and would be stored in a database if you run an application or if you run a website? Why would you take these information and store it in a database? Yes?
For logging.
Exactly, yeah, that's it. For logging, to know who's visiting your websites, where has it been sent from. So referrer would give you the URL that sent you this request. So imagine ChatGPT gives me an URL. I click on this URL, then the referrer will be ChatGPT on the site I'm visiting. So to keep good insight on who's visiting, why they're visiting, who sent them, what website what browser they're using, or anything like that. Some databases store HTTP headers, and those headers are sometimes injectable. So, user agent, injectable, refer, injectable, exporter for injectable, and cookie, injectable in certain cases, of course. But never overlook HTTP headers in SQL injection. So, never store user-controlled input in anything that could be compromised or that is confidential. Never trust user input. Never trust. All users are malicious. If you go from this part, you will never have any issues when you develop your website. So HTTP headers are user input, therefore attack vectors. Okay, now that we know all that, how do we evade all these filters and how do we evade everything using SQL injection? I see you're now interested with the word SQL evasion. So URL encoding. Probably because people already did a bit of competitions, things like that. So that URL encoding was very useful. Sometimes it works because your URL encode, you paste it, it's decoded when it's executed and done. So hexadecimal encoding as well. Sometimes just encoding your strings as hexadecimal. For example, here, if the admin string was blocked by a filter, you could encode it as hexadecimal and it would be decoded by the system directly. And last but not least of character encoding, Unicode encoding. Unicode, the string admin can be encoded in Unicode as this. And this method can bypass filters as well for when they check for specific ASCII characters. So admin, administrator, user, things like that might be blocked. You can bypass them with these things. Filter evasion, the second part. So you can replace your inputs. For those of you who already coded in Java or in C or things like that, you will see this double bar, this double pipe being used for OR statements in JavaScript, if I'm not mistaken. So yeah, OR statement in JavaScript. In SQL, specific dialects again, you can also use it to replace OR. Or to replace the end, you probably be using 2 %, things like that. So here, if you encode, and then you replace your input, you have something like that. And this does exactly the same thing, but it's just encoded, so it will bypass most of the filters, which makes it absolutely awesome. So yeah, that's something you can also do for evading filters. Also, something called no-quote SQL injections. So as you can see, every time we did do SQL injections, we had a quote at the beginning. Now you can also, what if I told you could use numerical values directly, use SQL comments, but not the usual SQL comments with the double minus, the SQL comments with the bar and the star. I'll show you later. And this is used if you put a comment instead of spaces or anything like that. It will work, and it will enable you to create a query as well. Using the concat function in SQL dialects, again, specific of you have concat, the concat command that can concatenate hexadecimal values and construct the string admin again, which is very useful when you have strings that are blocked. And spaces, sometimes they block spaces. What happens when they block spaces? That's a good question. So when they block spaces, you can comment or replace the spaces using, as I said before, the specific comments. So you have the two bars as well. As you can see here, instead of using everything, you can have just add the two bars. Add tab or new line characters. The tab and new line characters also work very, very well in replacing spaces, or alternate characters, URL encoded. For example, again, the tab or new line character, but URL encoded this time works perfectly as well for replacing spaces. So, last but not least, how do we prevent all this? Because it is quite dangerous, as you guys can see. It is quite easy to do as well. And if you have the proper knowledge, it is quite fast. So how do we prevent? You will hear this all the time. Use prepared statements. If you are in second year and you have Akim or Ashim, he will tell you, use prepared statements. If you have any security courses on SQL, use prepared statements. What does that mean? That means use statements which cannot be injected and cannot be executed with code when it's not meant to be. So prepared statements, parameterized queries. In Python, instead of using the small plus to concatenate, you would use interrogation marks, and it would be built differently, which would make it secure instead of just concatenating inputs with each other, making it absolutely unsecure because the user controls it fully. Validate and sanitize input. Even if you have parameterized queries, at the end of the day, validate your input. Has anything been launched since the query has been done? Monitor your processes. Maybe you block anything related to quotation marks. Maybe you block everything related to URL encoded, anything that can come to mind that could be used. Validate and sanitize, even if you already parameterize and prepare. Use list privilege account. As said at the beginning of the year, this is a method where you don't trust anyone and you always give the list amount of privileges to everyone. So even if there's a leak, no one is concerned. Disable verbose error. Very important. Debug mode. Worst enemy in that case. If someone tries to inject and he has a proper, nice error terminal with everything he needs, all the information, the line numbers, the whole statements, I mean, the guy is happy when he's seeing that. So disable the debug modes, the verbose errors. Disable everything. And put on firewalls. If you're really, really serious about your security and you really are not sure about your parameterization, and if you really made your queries and statement correctly, put a firewall. Doesn't bother anyone, and it'll just add an extra layer of security. Never trust user input. If you need to remember something from today, that's it. Never trust user input. So, last but not least, these slides will be available, so you will be able to have all the links. These are very, very useful tools in SQL injection automation. My favorite, everybody's favorite, it is probably the best in the game, SQL Map. The SQL Map, why does it have a little store? Because it's the best. I don't have anything to say. If you need a tool for SQL injection automation, SQL Map. It's called SQL Map because it'll help you map exactly how the database is made, what tables are in there, anything that is going on. It'll help you extract what you want to extract, drop the table if you want to drop the table, anything that you would like to do, SQL Map will do it for you. SQL Ninja, very, very useful as well. SQL Injection is a Java library, so it's fully made in Java. It's quite nice. And BBQ SQL, BBQ for blind SQL injection framework. This is designed specific for blind injection. It's not as versatile as SQL Map, which also handles blind SQL injections, but for only blind, maybe it's the best. And that's it. So that's it for today. Thank you very much. And hopefully it was not too boring and you guys enjoyed it. If you have any questions, always ask on WhatsApp, ask anywhere you want. I will answer as fast as I can. And yeah, that's it. Thank you very much.